Astronomers have detected high-energy gamma rays violently blasting out of a microquasar within the Milky Way galaxy. The microquasar, named SS433, is about 15,000 light-years from Earth. It comprises twin jets beaming deep into the galaxy. The jets are being generated by a stellar mass black hole in a binary system, feeding off material it's dragging off a companion star. A report in the journal Nature claims the discovery strongly suggests that electron acceleration, together with collisions at the end of the microquasar's jets, are producing the powerful gamma rays. The discovery is important because it offers a glimpse into more extreme events happening at the centers of other galaxies, which involve larger quasars being generated by supermassive black holes. The authors gathered their data using the high-altitude Water Cherenkov Gamma Ray Observatory. The detector is designed to look for gamma ray emissions coming from astronomical objects, such as supernova remnants, quasars, and pulsars. Scientists have detected over a dozen microquasars in the Milky Way, but only a couple of them appear to emit high-energy gamma rays. With SS433's close proximity and orientation to Earth, scientists had a rare opportunity to observe the extraordinary astrophysics taking place. The study's lead author, Professor Jordan Goodman from the University of Maryland, says SS433 is right in our local stellar neighborhood. So, using the high-altitude Water Cherenkov Gamma Ray Observatory's unique wide-field view allowed his team to resolve both microquasar particle acceleration sites. By combining these observations with multi-wavelength and multi-messenger data from other telescopes, Goodman and colleagues can improve their understanding of particle acceleration in SS433 and then extrapolate that data to their giant extragalactic cousins, the quasars produced by supermassive black holes. Those quasars are powerful enough to be seen right across the universe, visible some 13 billion light-years away. But because they're so far away, most known quasars have only been detected when their jets are aimed directly at Earth, just like only noticing a distant flashlight when it's aimed directly at you. In contrast, SS433's jets are oriented away from the Earth, and the high-altitude Water Cherenkov Gamma Ray Observatory was able to detect similar energetic light coming from the microquasar side. Regardless of where they originate from, the gamma rays involved always travel in straight lines to their destination. The ones that arrive at Earth then collide with molecules in the atmosphere, creating newer particles and lower energy gamma rays. And each new particle then slams into more stuff in the atmosphere, creating what's called a particle shower as the signal cascades towards the ground. The high-altitude Water Cherenkov Gamma Ray Observatory is located roughly 4,115 meters, or 13,500 feet above sea level, near the Sierra Negra volcano in Mexico. The detector is amazingly simple. It's composed of 300 tanks of pristine distilled water, each tank being about 8 meters in diameter. When the particles hit the water, they're moving so fast they produce shock waves of blue light called Cherenkov radiation. Special cameras in the tank then observe this light, allowing scientists to determine the origin of the gamma rays. To reach their conclusions, the authors of our story examined some 1,017 days worth of data, finding evidence that the gamma rays they were seeing were coming from the ends of the microquasar's jets, rather than from the central part of the star system. Based on their analyses, the authors concluded that the electrons they were seeing in the jets attain energies that are about 1,000 times higher than anything can be achieved in Earth-bound particle accelerators such as the Large Hadron Collider at CERN. The authors hypothesized the jet's electrons then collide with lower energy microwave background radiation which permeates space, resulting in gamma ray emission. If they're right, this is a new mechanism for generating high-energy gamma rays in this type of system, and is different from what scientists have observed when quasars' jets are pointed directly at Earth.